Hey y'all, we're out on site. We're going to show you how we diagnose a compressor in a residential heat pump, or that's the application that we're using for this, and then go through the process of replacing that. So I'm going to go over with you guys how you check a compressor. Hopefully you can see the ohm out there. That's just a simple continuity beep, and we're on a scan there for ohms. So you're checking a compressor, you want to check each lead to each other. We're reading 60 point something K, so that's way too much. Usually I'm used to these reading about 1 to 3 across each leg. They're all reading the same. And then you want to check these to ground. So you can go to the equipment ground, you can go to the copper, got the shakes here. So we're getting some ohms between one of these leads and ground, and you can also come right here and check it, this little metal piece in the back there. So we're getting a reading there. So when we came out originally a few days ago on this, the breaker for this unit was tripped, and the homeowner said every time he reset it, it was tripped. And we disconnected the compressor, turned it on. There's lots of ways to verify if the compressor is the issue. You always want to check your leads to each other, ohm it out. Like I said, normally on single phase compressors we see anywhere from 1 to 3 ohms, somewhere in between. They're usually all similar. And then you want to check each lead to ground. So you can go here, you can go to the equipment ground where the electrical comes into the unit. You can go to this disc again, I think I already said that, or you can go over to copper. I like that one. But basically leads to any ground in this piece of equipment. And now I'll go over the setup here for what we've got. So I call this a cheater cord. I was going to use this to run the vacuum pump off of. Pretty sure that's an OSHA violation, but I don't think they're going to be out here checking. When you don't have an outlet nearby, sometimes that works great. But we did pull an extension cord over. We got our recovery machine, got our gauges hooked up to the low and the high side. The charging, what I call the charging hose, is hooked up to the input side of the recovery machine. We've got the output going over to the pump. We're recovering into the vapor side, which is what the fill piece manual says to do, and then we're going to weigh the refrigerant out. So we want to see, oh, here's the data label. This unit holds 242 ounces. So you want to figure out how many pounds that is. You're going to take and divide that number by 16, because there's 16 ounces in a pound. So we got 242 divided by 16. So this thing should have roughly around 15 to 16 pounds in it if it was charged properly from the factory, if refrigerant hasn't been added, if there's not a leak in the system. But it just gives us a basis for how much refrigerant was in the system. So what I encourage you to do, regardless of what recovery machine you're using, is to follow the directions. If the directions are not on the side of the recovery machine that you're using, then you need to find the manual or Google it. So close all valves of the recovery cylinder and manifold, connect everything to the system as shown in the manual, which we've already done. Ensure filters are in place so I've always recovered through a filter dryer. This is not a bi-flow. I'm not going to turn it over so you can see the arrow, but this makes sure we're not getting any gunk into this very expensive piece of equipment here. And we swap this out, I don't know, probably every 10 recoveries or so, depending on the weight. We're not real consistent with that, but having it there is always better than not, even if it is dirty. So open manifold valve set knob to recover. So we go ahead, open everything up, and basically what these knobs are doing is allowing the refrigerant from here coming through this blue hose. This is opening this hose into this manifold, this piece here. It's just a big tube inside of there, and these are basically like ball valves, so these are all open. And then we want to open this to the tank. I'm going to purge everything a little bit. So that's going to get all of the air out of these hoses if there is any. Now we've got refrigerant going all the way through these hoses to this filter dryer, so we're not going to be pumping air into our recovery tank. And that's step 4. To purge air from hoses, briefly unseat hose fitting cylinder until vapor is seen. So we've got, I'm going to take it a step further and purge it all the way here. Oh. So we're good. I have my ball valve closed on this hose. All right. Open vapor valve of recovery cylinder. Press start to begin recovery. So this thing's pretty simple. Just follow the instructions.
This one?
Yeah. Okay. Let's set them up on this table. See if I have to get this wet. So, the pressure got too high. This tank's getting super hot. So we're going to take and put some water on it to try and bring that pressure down. And already you can see the pressure dropping here from just that little bit of water going over the tank. Also, on these tanks, you never fill them past 80% of capacity. So if it's a 50-pound recovery cylinder, you shouldn't be putting more than 40 pounds in it. The empty weight is usually stamped on the handle of the tank. So I believe these are like 27, 28 pounds. Yep, 26.2 pounds right here. I don't know if you can see that or not. So when this tank is full, or when it's at capacity, it shouldn't weigh more than 40 plus 26, 66 pounds. You can put more in it if you want to. I've never done it. Don't want to find out what happens when you do. And now that pressure's down where we can start again. So now we're all set. I was also going to say, if you don't have access to water to cool your tank, most of your recovery machines have a pretty powerful fan on them, so you can get the tank close to the back side on this one. This is actually the intake, and it'll help pull air across that to cool it. But obviously water is a lot better conductor of heat, so I had access to it, so that's what I used. Now we want to see how much refrigerant we took out. And we got 11 to 11.5 pounds. And this recovery machine creates a vacuum when it pulls it to make sure it's all out. Can't remember how many pounds we said it was supposed to have. Let's see here. It's 15 to 16 pounds, so about 4 pounds short of what it should have. So we'll see what happens when we go to pull a vacuum. Let's see here. So we're done. Let's see what these directions say. So set knob to self-purge and press start to empty the MR45. MR45 stops automatically. So I'm gonna set it to self-purge. Okay, self-purge is done. Close manifold and cylinder valves after self-purge is complete. So we're done, basically. Cancel that alarm. Now, I'm going to go over how we zoom lock for this. Always want to replace the filter dryer anytime you open up a sealed refrigeration system. No, go on.
My bad.
You're good.
I didn't even know you were out here. I'm so sorry.
No, we're not, but you're good.
I was upstairs because you said 1:30, so I was.
Oh yeah, we were running ahead of schedule. You're
so
you're
I saw
fine.
I woke up, I saw the text message, I was like, oh crap.
And one thing I meant to do and I got distracted was there was a little bit of a vacuum in the system, so really you should break that vacuum with nitrogen. So I should have introduced some nitrogen in the system. I just got that hiss. It's pulling air in, but you know, we're going to do a vacuum, so it's good. Just the least contaminants you can introduce into the system, the better.
Ooh. Okay. Where'd they go?
He took him inside.
Oh, he's here?
Yeah, he is here.
Oh, okay.
I think he was asleep.
Wouldn't doubt that.
Oh, there's some fittings in the truck, in the orange box. I need two 3/8 inch Zoomlock couplings. Alright, we're going to ream these. So when you use a copper cutter, it creates, you're basically pressing a disc into the tubing all the way around, and it makes, I mean, I don't think you'd be able to see that, but there's a little lip on the inside, and you want to get that off without the shavings falling back into the tubing, because copper shavings aren't good for things inside the refrigeration system.
This thing?
Yes.
You need two?
Yep.
Well, look, because there was two left.
Awesome. And so, we want to clean both ends. If you've never used Zoomlock before, I'd encourage you to read the directions. I like to take it a step further over this cloth and use some, I call this emery cloth. I've heard people call it sand cloth, but just want to get a nice clean finish on your tubing. Okay, now I don't have my marker. But this is a guide for how far it needs to go, so I'm just going to score it. And then this as well. Even though this just came out of the box, I want to make sure we rub it down, get any buildup or corrosion that could be on it off. Okay, and those ends look pretty good, and we're going to mark this. Ideally, you'd want to use a marker, unless you're confident in your abilities to see score marks. And then you want to line up the edge of these fittings with those marks. Alright, so that's done. There's one up here. We're doing 3/8. My Milwaukee press tool here goes in. of these, but the industry hasn't caught up with this yet as far as manufacturers go. There's not any compressors that I'm aware of where you can use a Zoomlock fitting to put them on, and a lot of your service valves coming off of your equipment aren't long enough if you cut the bell housing off to use a fitting to attach your lines. But the beauty of this is there is no brazing. You're not having to use nitrogen to purge. It is a rather expensive setup to get going, but it's a huge time saver, and you're not having to lug torches around. I have yet to have one of these leak, so as long as you follow the instructions. And then this thing will tell you if you got a good crimp. You just put it on the crimp spots, work it around, make sure it moves freely, and you're all set. So this one's good to go. Just want to show you guys how to do that, or how you use this. Can't remember how this goes back in here. And of course we're going to have to braze the compressor in. We'll get to that. While we were recovering, I went ahead and took these bolts out. There's one in the corner back here, one there. They have a 1/2 inch head on them. I use this ratchet socket extension, and I've seen a lot of guys take and braze these compressors out. But the issue there is, and I'm not going to say I've never done it, but if there's any pockets of refrigerant in here, or say there's a restriction and you've got pressure in here and you braze this out, you know, you're going to get a lot of hot gas and oil, possibly on fire, coming out of there. So I don't do that anymore. I try to cut all these out, and then if you need to, bring a little extra copper. I'm just going to pull this over. It's not ideal, but that's what we're going to be doing. And also, down here towards the bottom, we have this crankcase heater, and I went ahead and loosened it. Let's go ahead and take this off now. I'll pull up over the top, get it out of the way, and this compressor is ready to come out. And I need to put these rubber grommets on this new one. And there's a look at what the edge looks like that we ream out of these copper tubes. So I'll move the compressor over from where it's supposed to be to line these up, and then once I get it brazed in, I'll move it back over to where it's supposed to be and put the bolts in. This is a new Calgon thermo trap. This is better than using a wet rag. All right. And we're going to set up our nitrogen. And if you haven't seen our video on brazing with nitrogen, I'll put it up as the suggested video at the end of why this is important. And this little tool here, why it makes it easy. Alright, we're letting the rest of the nitrogen bleed out, and I'm going to go ahead and start this evacuation / vacuum. All right, so we got the vacuum done, evacuation done. Charging up the unit now. Remember, we want to do 15 to about 15.5 pounds. We're getting there. And just doing the wiring up top. You always want to look at your wiring diagram. Make sure you're putting them where they're supposed to be. Check your capacitor. We checked this capacitor when we were out here before, when we diagnosed the compressor. Let's see. Oh, the screws on the contactor. You saw me tighten those down? Those must have been loose. That could be a cause of the compressor failure at some point, unless somebody came out here before us and loosened those up. But having those tightened down hold the clip in that those male terminals are on. Show you what I'm talking about here. So we've got this brass colored piece here under this Phillips head. That was loose, so that whole brass piece on both sides was loose. I mean, you want to have a strong connection because all of your amp draw is coming through here, except for I think the condenser fan comes off the back side into the board to do defrost. But putting these connectors on is key. I never take stranded copper and put it into the contactor screws. You could take a I terminal and put it on here too if you wanted to go there, but I would never put stranded copper in a terminal like this. You would need a lug like this. That's what I would call that, as a lug, to do that. But this style of connection is not suitable for stranded copper or stranded aluminum, in my opinion. So we're at 15 pounds and 1.25 ounces. We're going to have to put this into cool mode for it to take any more, and then we'll check the charge against the pressure chart on the unit. Yeah. All right, guys and girls, that wraps up this repair. We got the unit, the condensing unit, cleaned up and got some new Armaflex on the suction line. Made sure the pressures were good. They're where the manufacturer specs on the inside of that panel said they're supposed to be, within reason. And then we checked out a ductless unit this customer had on site he was having issues with. And that's it. If you like this video and want to see more content like this, please like it and subscribe and share it and send it to all your family and friends. See y'all next time.